Right. Continuing from the topic that I've discussed much earlier on the first video on the basic concept of matter, where I've discussed number one, describing matter, describe matter briefly, explain the changes in the state of matter, determine the melting point and freezing point. Now, determining the melting point and freezing point of matter will be discussed based on the experiment that is conducted in the laboratory. Now, the experiment that is conducted is actually using naphthalene. Before I go on further on the explanation for the experiment, let me just refresh your memory on the changes of matter. Now, matter can interchange between solid, liquid, and gas. What you need to know here is the condition where the changes take place. Condition means, let's say solid changes to liquid. Now, we all know the process is called melting. But what actually happens during the melting process? So the point here to remember is about the kinetic energy, all right, and the attraction of force. All right, so you must be very clear on terms to use. Particles. The solid particles are closely packed. So when the solid particles absorb enough energy, the kinetic energy of the particle increases. So what is stated here is the characteristic of the solid particle itself. But what happens when the solid particles absorb energy? So that is different. So you need to talk about the particles. Once it's absorbed energy, the kinetic energy increases. When the kinetic energy increases, of course, the attraction forces between the particle decreases. Now, why the particles need to absorb energy? The energy is coming from the heat itself, all right? So heat and energy is the same. So when the energy is absorbed by the particles, the solid particles are able to break from each other. So when they break from each other, their kinetic energy increases because they have energy, and thus they are able to change to liquid particles. Now, when the process happens from solid towards becoming gas, where the particles is moving further away, you need heat. Whereas when the particles actually go the other way around, meaning that the particles actually release energy, they become what we can say as closer together. So being close together, all right, will release energy. So this is the opposite that takes place between the particles, right? So it is the opposite. As you look at it, the concept is the opposite, meaning that from being close together to being far apart, okay, this way, close together to far apart, you need energy. The particles need energy. When it convert the other way around, that means from being further away to becoming close together, it will release the energy. All right. Now, how do we further explain that particles actually undergo, all right, undergo the change in matter? That means how do we explain the process is through experiment. Now, before I go to the melting point and freezing point, you need to know about matter. Now, matter can be divided into two categories or two groups. You have your element and you have your compound. So element is divided further into atoms and molecule, whereas compound is divided into molecule and ion. Now, if you look at it in a simpler way, is you know that matter is anything that occupies space and has mass. Now, because it occupies space and have mass, so meaning that matter actually consists of particles. Now, when it consists of particles actually can be divided into three kinds of particles, right? Now, three kinds of particles here are what we call as atom, molecules, and ion. Now, when we have atom, molecules, and ion, they make up different kind of matter. As we know, matter is all around us, but of course, matter come in different size and shapes. So that is why matter can be divided into two different group, which we call as element and compound. The only difference between element and compound is element, it consists of the similar atom. Like for example, element is divided into atom and molecule. So this molecule, in order to be called an element, it must be made up of same atoms. So that's why you have oxygen as an example of molecule. Apart from oxygen, you also have nitrogen. Nitrogen also is a molecule, which is element. So element means it is consists of the same atom. All right. Now, of course, compound have molecules, but the only difference between compound molecules and element molecule, compound molecule consists of a molecule that is made up of two or more atoms which are different atoms. Like you have water as an example, then you have carbon dioxide. All right. So there's a difference between molecules in element and molecules in compound. Then you have the term ions. That means particles also consist of ion. Now, ion here is talking about the positive ion and the negative ion. So normally the positive ion is written, all right, on your right, whereas the negative ion is written on your left. Okay, there's another term that we call positive ion, which we call it as cation, and the negative ion is called your anion. Now, let us go through and just have a quick recap, right? How an ion can exist from an atom. Now, as we all know, all right, elements that is around us, some are stable. When I say some are stable, that means there are elements that exist on their own, such as group 18 elements, helium, neon, argon. Now, that one is further discussed in chapter 4. But for now, how do we get atoms? How do we get ions? The thing is, how does an ion exist? Now, all ions actually, they come from atoms. Now, why atom forms ion? There's a question mark here. Why atoms forms ions? So the only reason is atom that is not stable. Not stable means they haven't reached octet or duplet. So we're going to discuss octet, duplet later on. So that is not stable. Not stable means the particular atom. Okay, if you look at the valence shell, the valence shell is the shell at the furthest away from the nucleus, the end shell. So that's called the valence shell. So we'll discuss this further. So the valence shell hasn't reached either a duplet or octet. Duplet means in order for that atom to be stable, it has to have in the valence shell 2 or 8 electrons. Now, when must it have 2? When it must have 8? Later I will discuss. But for now, any atom that forms ion, the reason will be because it's not stable. So stability is achieved when an atom becomes an ion. So for sodium atom here, it will donate 1 electron here to become a sodium ion, which is a positive. So now you can see it has 8 electrons here. So this is stability. All right. So either we'll have 2 or 8. And here the same thing. All right. We look at chlorine atom, the valence shell, the N shell, hasn't reached either octet or duplet. So meaning that here it will receive 1 electron. Now, how is it going to receive 1 electron, or donation of electron, or receive of electron? Is through reaction. All right, through chemical reaction. All right, that is on matter, particles, molecule, ions, and atom. Okay, let's go to activity 2.2. Now, activity 2.2 is explaining more or less an experiment to find out the melting and freezing point of a substance that we use, that is naphthalene. Now, what is the meaning of melting point? Melting point is the constant temperature. Constant, that means it only consists of one temperature when a substance changes from solid to become liquid. Freezing point, on the other hand, is also a constant temperature. Why we say constant? Because any substance will have only one melting point and freezing point. So there's no two substances in the world with two melting point and two freezing point. So every substance are unique in terms of melting point and freezing point. So in that experiment, you are actually going to find out, all right, what is the freezing point and melting point of naphthalene. So this is the setup of the experiment. All right, so heating of naphthalene need to be done in a water bath, all right, because the melting point of naphthalene is low. So if we directly heat the naphthalene, number one, it evaporates quickly, and number two, the heating won't be in it won't be distributed evenly. That means the heating process won't be distributed evenly. That means we need the heat to distribute evenly in order for us to collect the data, for us to read the reading. All right, because we are supposed to actually read the thermometer reading every 30 seconds. Same thing, when you want to cool down an naphthalene, you put it inside a conical flask to allow, all right, even cooling. All right, even cooling. Even means what you can say is the cooling process will happen evenly at an even process, so that we can collect the data. It's easy for us to collect the data. All right. Now, how we conduct the experiment, all right, is you need to actually, all right, fill up 1/3. So these are the procedure. I'm sure you can read it. Now, the important point is you must have a water bath. So normally water bath is used when you want to do heating for any substance with a low melting and boiling point, right? So the heat is transferred from the water to the substance. All right. Now your reading is collected every 30 seconds. All right, until it reaches 90. All right. So once it reaches 90, we don't have to collect any more reading. We can stop the heating process. So once you stop the heating process, you can remove the boiling tube. All right, so this is what you need to do lah. Remove the boiling tube from the water bath, dry the outer part, and further you put it in a conical flask. So stirring is one of the, all right, when you discuss about what are the steps taken, all right, okay, what's the precautionary steps taken. So you can say that stirring naphthalene continuously, all right, heating naphthalene in a water bath. So those are actually precautionary steps you can take to ensure that you get the correct data lah. All right. So once done, you need to plot graph. So your graph is plotted, all right, temperature against time. All right. So time will be in your x-axis and your temperature, your y-axis, because y-axis is your responding variable, right? So once done, all right, once you draw the graph, all right, so the graph will look like this. This is a sketch of the graph. So your graph need to be on a graph paper. So you will get the shape where the graph goes up, temperature increases, then after some time the temperature becomes constant, then it increases. Now this is a very important point to remember here. That is, why does the temperature remain constant for one period of time? Now this is because when you are looking at a state of matter, when the matter is changing from solid to liquid, all right, there's two states. One is liquid and solid. Why? Because when the particles, like I said earlier, particles need to absorb heat. In order to absorb heat, it needs the reason why it absorbs heat is to gain energy. So the energy gain, all right, is actually to break the force of attraction. All right, so that's the reason. So the temperature remains constant because the particles absorb enough heat energy and they move faster, all right, to change from solid to liquid. That means in C, all the substance have already changed to liquid. All right. Whereas in D, all right, D, it is still in liquid form. But why is the temperature increases? Because when the heating process actually continues, the particles still absorbs energy, and if you continue the process, of course the liquid will change to gas. All right, so pay attention to the graph where the temperature is constant. All right, the temperature where the graph is horizontal. So this part is where you get your melting point. And the other way around is both graphs are reflection of each other. So the melting point, like I said, the cooling process, all right, the cooling process or the freezing point actually is when the particles, all right, release heat, all right, to the surrounding. So during the freezing, the cooling process, or we call it when we cool the substance, the naphthalene, actually the naphthalene actually will release energy to the surrounding. So at this point here, the freezing point and also the melting point is actually equal to each other. All right, so if let's say a substance A melts at 60 degrees, the substance A will also freeze at 60 degrees. All right, so freezing also will take some time because what is going on is heat energy that is lost to the surrounding is balanced by the heat energy release. So that's the reason why the temperature remains constant. So there needs to be a balance between heat loss and the heat release. All right. Now we move on to 2.2. Now 2.2 will be on atoms. All right. So before we talk about atoms, okay, these are the scientists that contributed to the development of the atomic structure. Contributed to the development means there's always initial structure that is not perfect, okay, compared to the structure which is accepted until now. All right, is different because as you know, all right, in history, when you go down to history, when you talk about atom, all right, the first scientist will have his own model, and of course after sometimes another scientist will have a better model until they come up with a perfect model. So this is called development. All right, we call it as history lah. So we need to go down in history and find out how was the atomic structure, which is what we call as the this is the structure actually, the Chadwick atomic model. All right, this is the structure until now has been accepted lah. All right, so initially, all right, initially Dalton, all right, so you need to know Dalton, all right, John Dalton, he actually said that matter is made up of atom. So, and also he said that atom is the smallest part of a matter. So this is what he said lah. This is very important. And then he structured the atom is just a sphere. Now further on you have Thomson. Okay, Thomson. Now Thomson discovered what we call as electrons. All right. So after Thomson, all right, we have Rutherford. Rutherford discovered protons. So still it's not complete lah, even though after Rutherford, right, we have already discovered electron and proton. Now further up we have Bohr. Now Bohr's atomic model is much different from what was stated by Dalton, Thomson and Rutherford, because if you look at the structure, it is in a sphere shape, right? When you go to Bohr's model, all right, you can see the difference where you have what we call as electron shell. Now electron shell, all right, and what you call it, you need to understand that electron shell only occupy one electron. One electron will occupy one shell. All right, so if you have like 20 electrons, then you will have 20 electron shell. Now let's move on to the Chadwick model. All right, Chadwick model, the last part is he discovered what we call as neutron. All right, he discovered neutron. Right, so now how are we going to remember the name? So we can form a mnemonic. So the mnemonic we can form here is Dalton thought Rutherford. Okay, Dalton thought Rutherford is Dalton thought Rutherford is Bohr's, all right, Bohr's let's say Bohr's close friend. Okay, see what Chadwick. Dalton thought, okay, again Dalton thought, okay, Dalton thought Rutherford is Bohr's, okay, Bohr's close friend. Okay, so you can use this as your mnemonic to remember the sequence. So Dalton thought, again, okay, Dalton thought, all right, Rutherford is Bohr's close friend. Okay. Okay, now we go to atomic structure. Now, atomic structure is where you need to represent, number one, the atoms. All right, how you represent the atoms. Now, before that, all right, atoms, okay, symbol of atom can be put into standard represent. When we represent an atom, we can represent in a standard representation of an atom. All right, so this is what we call as standard representation of an atom. So this is in 2.3 lah. All right, so 2.2, let me just go back and tell you. So in 2.2, you need to state the subatomic particles in atom of various elements. So an atom, you have your electron, proton, and neutron. So even looking at the scientists, you already know the subatomic particles. All right. Compare and contrast the relative mass and relative charge of proton, electron, and neutron. So as we know why, okay, we can ask ourselves why is that electron moves around the nucleus, whereas proton and neutron stays in one position. Now this got to do with the relative mass. Relative means comparison mass lah. Alright, so the lowest relative mass is your electron. So this is what is stated here lah. Relative mass of electron is 1/1840, means that is the lightest. Alright, and then the part is the sequence of the atomic structure of model. Alright, based on Dalton, Thomson, Rutherford, Bohr, and Chadwick. So the sentence is Dalton thought, okay, Rutherford is Bohr's close friend. Alright, now let's move on to the next part, where you need to know about the atomic structure. Right, so here you need to define what is proton number and nucleon number, determine the nucleon number, proton number, and number of electrons in an atom. Alright, write the standard representation of an atom, construct an atomic structure diagram and electron arrangement. So atomic structure diagram is this. Okay, this is what we call as atomic structure diagram, right? Okay, so here, then only you go to 2.4. So we will cover till 2.3. Now, when we talk about the atom, all right, the first part is you have what we call as many elements existing around us. All right, so how do you differentiate each and every element is to the proton number. Now, proton number is different, okay, with different elements, okay. So proton number is different. You need to know proton number is different for every elements. So now there's no two elements with the what I mean is the same proton number. So that's what I mean lah. Now let's move on to the definition. All right, definition. So proton number, right, is stated here. Proton number is the number of proton. All right, where's the proton? In the nucleus. So it's very simple. Proton number is the number of proton in the nucleus. All right, so nucleon number is not nucleus number. Be very careful. Nucleon number. So nucleon number consists of protons and neutrons. So nucleon number is the total. Why we say total? It is because nucleon number consists of protons and neutrons. So the total number of protons and neutrons where? In the nucleus. Alright. Then we go to the, this is more or less calculation. So if you're given, if you know the calculation, so if you're given, let's say for this question, nucleon number is 39. Potassium has 19 protons. So how many neutron and electron does a potassium atom have? So here, there's one part where you need to determine how many electrons, because so far nucleon number is the total number of proton and neutron. It is not stated electron. So electron actually is the same as proton. If you got 10 electrons, you got 10 protons. Meaning that if you know the proton number, all right, you will know how many proton, how many electron, because every atom initially they are neutral. All right, before they become stable, they are neutral. Neutral means they have equal number of electrons and protons. So that is what you need to know lah. Okay, this is a standard representation. You have A and Z. A actually represents your nucleon number and your Z represents your proton number. So then you go to the last part, which is your arrangement, or we'll call it the atomic structure. Now, atomic structure, the rule of a thumb is you need to know how many electrons occupies each shell starting from the nucleus. You go from in to out. All right, it's just like a car. All right, if you have a car, how many passengers maximum? How many maximum passengers can occupy the space in a car? So it's 5. Maximum means it can be less than 5 or less, but not feasible to be more than 5 lah. Alright, same here. First shell only it can occupy 2 electron maximum. That means it can occupy 1, 2, but not 3. So what if you have 3? 3 means you have 2. The 1 extra electron will occupy another shell, the second shell. So the second shell maximum 8. Okay, so you need to know the term maximum means that is the cutoff number. Cutoff number means can be 8 and below, cannot be more. Alright, and also the third shell you only learn till 20, so the third shell will be also maximum 8. So this is how you can determine the electron arrangement, what we call as electron arrangement. So let's say aluminium here. Alright, aluminium, as you can see here, if it has 13 protons, alright, because the atom, if you have 13 proton, you have 13 electrons. So how do you arrange 13 electrons? So first shell occupies 2, then you have balance of, alright, 11 electrons. So the second shell will take 10 electrons. Then you have balance of 3 electrons. So the 3 electrons occupy the third shell. So the third shell is called your valence shell. So you need to actually arrange the electron based on the number of electron on each shell. Right? So that's called arrangement of, okay, what do you call it? Arrangement of electron. Okay. So with that, I've concluded till, alright, I've covered until, alright, this part of the chapter, alright, 2.3. Now, earlier I said about duplet and octet. Now, duplet and octet is referring to the valence shell. That means the outermost shell is called your valence shell. So normally, alright, if an atom only have one shell, one electron shell, that means the atom is smaller. So if it has one shell, that means the valence shell, in order for it to be called a stable atom, the valence shell must have 2 electrons, right? So that's called duplet, right? So if an atom, okay, initially have only 1 electron in the first shell, okay, this shell have only 1 electron. So 1 electron hasn't reached the maximum number for that shell. So this shell, the maximum number is 1. So if it has only one, maximum electron is 2, but if it has only 1 electron, it hasn't reached the maximum electron. So it is not stable. So in order to become stable, it has to, alright, what we say as, okay, let's say we take hydrogen, right? Hydrogen, okay, further on, when you study, hydrogen can become a positive or negative because hydrogen is the smallest atom with only 1 proton, 1 electron. So when you have 1 in the first shell, of course, that because of that 1 single electron, it has 2 choices, whether it receive another electron or donate another electron. So in other words, okay, for your level, you learn that hydrogen will donate 1 electron, right, to become a positive ion. So that's why you have hydrogen ion H+. Alright, that is what we mean by duplet. So octet means when it has maximum 8 electron. So dup 2 oct 8. So that is all until now. So I hopefully you understand what I've explained so far. Now let's look at a simple, video regarding what I've explained just now, right? Let me go.
Description of Rutherford's atomic model. Here we have Rutherford's model of an atom. Click on the nucleus and/or the electrons to further. An atom consists of a small, dense. Click on the nucleus and/or the electrons to further explore. The electrons are revolving around the nucleus. You have completed this activity. Assess your knowledge. Follow the instructions to perform. Select the structure of a carbon atom. Well done! You have successfully selected Rutherford's atomic model of carbon. Select the structure of a magnesium atom according to Rutherford's. Well done! You have successfully selected Rutherford's atomic model of magnesium. You have completed the assessment. You scored well, and you. Exploring atomic number. The periodic table is a systematic arrangement of elements into vertical columns called families or groups, and horizontal rows called periods. In the periodic table, elements are arranged in order of increasing atomic number. Let's find the atomic number of an oxygen atom. An element's atomic number is the number of protons present in the nucleus of that atom. Thus, the atomic number of oxygen is 8, as it contains 8 protons. The atomic number is represented by the symbol Z. When you look at an element in the periodic table, the number located in the upper left corner of the square is the atomic number of that element. Go through the periodic table and click on any element to find its atomic number. Element, nitrogen. Go through the periodic table and click on any element to find its atomic element, sodium. Symbol, Na. You may continue exploring the atomic numbers of the elements or select Skip. Element, aluminum. Symbol, Al. You may continue exploring the atomic numbers of the elements or select Skip to proceed to the menu. Element, you may continue exploring the atomic numbers of the elements or select Skip to proceed to the neutrons. The nucleus is surrounded by electrons. Protons are positively charged particles, and neutrons have no charge. Thus, the nucleus of an atom is positively charged. Overall, an atom is electrically neutral because it has the same number of electrons as protons. Scientists' understanding of atoms continues. Move to the highlighted area using your controller. Models of a magnesium atom. Select the highlighted label to view the corresponding model of a magnesium atom. J.J. Thomson proposed a model of the atom in 1904. His model suggested that an atom consists of a sphere of positive charge with negatively charged electrons embedded inside it. Select the highlighted label to view the in 1911, on the basis of the alpha particle scattering experiment, Rutherford proposed a nuclear model of the atom. According to Rutherford's model, an atom consists of a small, dense, positively charged nucleus located at the center of the atom, while negatively charged electrons revolve in empty space around the nucleus. The electrons in Rutherford's model are revolving around the nucleus in well-defined orbits. Scientists have since learned that the orbital revolution of the electron is not expected to be stable or well-defined. This is the drawback of Rutherford's atomic model. Select the highlighted label to view the corresponding model of a magnesium atom. In 1913, Niels Bohr described a new arrangement of electrons in an atom to explain its stability. According to Bohr's atomic model, the electrons move rapidly around the nucleus in fixed circular paths called energy levels, denoted by the numbers 1, 2, 3, and so on. A magnesium atom has 12 electrons. You can see that the number of electrons in the K, L, and M shells are 2, 8, and 2 respectively. You have completed this activity. Select OK to return to the menu and assess your knowledge. Follow the instructions to perform the assessment. There are 2 substances on the table. The petri dish contains. Select the petri dish containing carbon to view models of a carbon atom. Move to the highlighted area using your controller. Shells A 4, B 2. Right. The Bohr atomic model of carbon has two. Move to the highlighted area using your controller.